Good morning and welcome to the post-flight crew press conference for the STS-62 mission. That was the 16th mission of Columbia and the 61st mission in the shuttle program. I'll turn it over to the crew commander. He'll reintroduce the five-member crew to you, and then they'll talk about their mission. I'll turn it over to John Casper.
Thank you, Kyle. Welcome everyone to our press conference, post-flight press conference. I'd like to start off by introducing the crew again. On my far left, Marcia Ivins, mission specialist. On my left, our pilot, Andy Allen. On my right, mission specialist Sam Gamar. And on our far right, Pierre Thuet, mission specialist. What I'd like to do now is to run the movie, and we'll all narrate parts of the movie, so if we could start that. The little logo showing our crew patch. Of course, each crew gets a chance to design their own individual patch. And some shots of suiting up before the flight here, with a few scenes of each crew member as we don our pressure suits, landing and entry suits. Pilot Andy, a little note home to his kids, Jessica and Meredith. You're taking it easy here after you get suited up. And Sam with his friend Theodore. This is a little teddy bear that has traveled around the country and now around the world. It's given to different travelers with a little note about where it's been, and it took quite a journey, quite a voyage this time. Marcia, and you can see all the crew is fairly relaxed. This was an experienced crew with 9 flights among the 5 of us before we flew. Walking out to the launch pad, and great weather for a launch that day.
We've all been here before, and you can see some of the water deluge getting us ready to go. And it is still a thrill each and every time we do it. 6 seconds prior is main engines. And at T0, we get the solid rockets to light off. From the inside, when the solids light off, we definitely know we're going somewhere. We don't know exactly where we're going, but we know we're going. It's a nice ride to get through there. There's a lot of vibration there in the first stage. And it is really a tremendous kudo to all the people that make this work. To me, the most important part of the mission is the first 8.5 minutes, and it was flawless all the way up. And the people at the Kennedy Space Center deserve, to each and every one of them, a heartfelt appreciation for how they make this look and how easy they make this look when we know the thousands and thousands of checks that it takes to make it all work as well as it can. This is the most versatile vehicle that we take into space anywhere, and it's got so much capability. Getting it there is their work, and they do it flawlessly again. SRB separation at 2 minutes, about 150,000 feet. Right smooths out quite a bit here. We're about 2.5 Gs on our bodies right there. Get up into space at 3 Gs. We dropped the external tank off. The SRBs are recovered in the external tank. We tried to follow it as it started its journey back into the atmosphere. This is going over some of Africa.
Now you get a shot of our payload bay. It looked pretty full to us when we looked out the window and opened the doors. But USMP in the front, OST in the back, the EDO cryo pallet in the very aft end of the orbiter, all the various experiments that were going to be conducted, the limited duration candidate materials exposure experiment on the left, and then the dexterous end effector behind it on the left. You can see USMP again on the right there. And then the SSBUV, the shuttle solar backscatter ultraviolet experiment on the right there. Now this USMP was one of the primary payloads, and USMP was what we've talked about. It was telescience, and this is a shot of the Marshall Payload Operation Control Center, and they sent almost 10,000 commands to their payloads throughout the mission. This is some folks sitting at a console getting ready to look at some of the dendrites that were developed during the isothermal dendritic growth experiment. And this is what they were looking at, and this is what helped them to modify the experiment during the mission. The EISG glow portion of OST, you can see the little nozzle there right in the middle of that plate, which is where the nitrogen was released. Of course, we did an ohms burn to lower altitude to 105 miles. This is what you see, what happens inside during an ohms burn. And the purpose of that was to try to maximize the glow. During all the gas releases, Marcia and I were busy photographing from inside the cabin to complement the sensors that were in the payload bay that were observing the glow phenomena. And this is the two of us with our little red lenses on our flashlights taking pictures of the glow. This was a 35 shot that I think Marcia took, 35 millimeter shot of the glow.
One of the new technology demonstrations that we had on this flight was a dexterous end effector. Here you can see Marcia coming in to grapple the magnetic attachment tool. And of course, this is a little bit different than what we've used in the past. The RMS has always used the mechanical apparatus to grapple payloads. In this, we used a magnetic. There you can see the tracking mirror, or the tracking target in the mirror, and one of our office views on orbit here. We're passing over the Bahamas during the operations.
The task was a multiple task, looking at how you would assemble possibly structures in space like a space station. We had a couple of feedbacks into the cabin. At the bottom there was a force torque sensor, and the top was the end effector, or the cameras. The little flashing lights in the center of this mirror, big mirror, is a camera in the payload bay, and it looks at a mirror now on the end effector. And data was gathered on this to understand how accurately we could move a target if you couldn't see it. This could be important later in assembling a space structure when you can't actually see what you're doing, but you have to mate two fairly large pieces of hardware together, and it worked just fine. You can see the arm here has this board at the bottom of it with some pegs at the end. We basically inserted pegs in the holes, and found that we could do this to a tolerance of about a 60 thousandths, which is pretty small. The force torque sensor display here indicated how much forces we had in 6 directions, and it allowed us to basically feel what we were doing with the end effector, and it worked great. Here we are again simulating a space station task. This is one of the biotechnology experiments from BioServe in Colorado. These are rosy periwinkle sprouts, which we grow by just inserting water into them when we get on board. As it turns out, the root of the rosy periwinkle is one of the major cancer fighting drugs that we have, and they find that it grows more pure, or the cell remembers to make more of its drug basically in orbit than it does on the ground. We took these little tubes out and photographed them to see how things were progressing and how things were growing. Now, if you look in there closely, you see a little guy swimming around in circles. That's a brine shrimp. We grow these because they spend their entire lifetime in the duration of our flight.
This is the commercial protein crystal growth experiment that Marcia and I worked on every day, or actually 3 times a day for the entire mission. We took video of the top tray, that experiment, and you can see inside the solutions there, you can see what's forming, the crystals that are forming. This was the first time I've had an opportunity to work with one of these experiments, and it was pretty exciting to see the actual growth of the crystals, and knowing what that will do for the scientists on the ground to help produce better drugs to fight disease. We had another APCG on board as well, and then the PCAMs were another crystal growth experiment.
This particular shot is of the MODE, the Mid-Deck Zero Gravity Dynamics experiment. This is a characteristic or representative truss structure of a large space-type truss. This is the second time this has flown, previously on 48 and now on 62. We find that over the course of the flight, those protocols that we repeated from the previous flight, STS 48, overlay almost perfectly. Again, we spent about 9 days working on this particular experiment and collected some 9 gigabytes of data that are now being analyzed by students at the Massachusetts Institute of Technology and the staff there. This particular shot is during one of the educational DSOs that we participated in. This is a downlink video, and of course has been recorded on board by our equipment. And John and I participated in a number of blood chemistry analysis type experiments, testing some new prototype hardware. Actually, this stuff is commercial hardware that's off the shelf, but we're looking at applications for long duration space flights. Blood chemistry is something obviously that you have to watch very carefully on a long duration mission to constantly check the health of the crew members on board.
What we're trying to show here is a couple different things. The first thing, I am in our lower body negative pressure suit, which is a device that's trying to help us readapt to gravity when we get home by creating a negative pressure in the lower half of our body, which will help our fluids go back down into the lower half of our bodies, and that will help us readapt a little bit better when we get home. One of the other things you can get out of these scenes, this scene and the next one that is coming along, is this area of our middeck was everything to us. It was every room in our house all put into one. We've got Marcia and Pierre working on protein crystals. Sam and I are working in the LVMP, as well as Moda's in the background there. This is our laboratory, our gymnasium, our kitchen, our bathroom, our sleeping area, bedroom, and this is our home.
And our shower, taking a sponge bath for 14 days, you know, there's some parts you miss here. And getting your hair clean is easier for some of them than it was for others of us. However, we carry some stuff on board that works pretty well. They all had to get out of my way when I was doing my hair. But you can see that doing this without gravity is not as easy.
And we always have the obligatory eating scene in the movie, and the one thing most people don't think about when you're eating up there is what if you need some seasoning. So we carry salt and pepper on board, but it's not the kind that you shake, it's the kind you squirt. It's salt and pepper that's put into a solution with water, and you just squirt the salt and pepper into your food and then stir it up a little bit, and you can season your food that way, and that's what I'm doing here. That's beef tips and mushrooms, by the way.
Now our laboratory, what was our daytime laboratory and the dining area, kitchen, has now been conformed and transformed into sleeping quarters. And here you can see Andy up on the flight deck, Marcia in the airlock. And as you pan around, John and I were on the starboard bulkhead, sleeping there, and Pierre will ultimately see up suspended from the ceiling. Sleep is very comfortable. You feel fully supported. You can see the natural position that the body kind of assumes with the hands and the arms out, extended out in front of you, and that's real. The sleep restraints just keep us from kind of banging into each other, although it would not be necessary.
Another one of our duties on board is taking pictures. We took almost 10,000 pictures while we were on board. Every time any of us would have a minute, we would get upstairs and work one of our cameras. We had a 90-millimeter camera, we had 70-millimeter cameras, as well as our 35-millimeter on board, plus our movies. This first shot is just a shot looking down the Gulf of Aqaba, down into the Red Sea. Sinai is on the right there, and Saudi Arabia there is on the left. And from our altitude and 39-degree inclination, we just got a real beautiful glimpse of most of the habitable Earth. Some of the Himalayas chain with Tibet and China on each respective side. We looked real hard to see if we could find the Great Wall of China, and unfortunately, some of the best views of it were during our sleep periods.
This is a tropical cyclone Latane that was in the Indian Ocean during our flight. We got some stills of this as well as some actual video of it, and we went on 2 consecutive passes. We basically went right over it. The thing was so huge that we saw it twice.
Cold water clouds, or closed cell clouds, what they're called. These are off the coast of Chile, and they made such an interesting pattern that we photographed them almost every time we went over them. They are caused as a result of a high pressure over cold water.
Now, this is one of our U.S. passes here. We're coming in over the San Francisco Bay, Oakland Bay area, San Joaquin Valley to the further to the south there, the tail, and eventually be coming over the Sierra Nevadas and pushing out across towards the East Coast. We had 4 daylight passes every day, typically in our afternoon. Now you can see the Sierra Nevadas, the snow-capped Sierra Nevadas coming into view. There's a small lake that is just, let's see, I don't see it now. Mono Lake, I think, just disappeared off to the right side of the screen. The U.S. passes, though, were pretty spectacular, and again, over the course of 14 days, we had different attitudes, and we were able to see parts of the country that had not been photographed before. Las Vegas now is coming in right onto the tip of the tail. They're passing off the center. And now we're going to come in with Houston is just off to the right side here, and we'll come in over the coast in Galveston Bay. Now you can see the Gulf Coast coming into view in Galveston Island.
This is a pass over the Great Lakes, Lake Michigan on the left, Lake Huron in the middle, Lake Erie to the right, and from this was sort of the apex, our 39-degree inclination. We could look well up into Canada, as you can see here, Hudson Bay right up on the horizon there. That's Lake Erie that's coming into view now. A lot of that part of the country is snow-covered this time of year. And this is Cape Hatteras, the Outer Banks, North Carolina. Looking on up the coast to the Norfolk, Chesapeake Bay area.
Here's a little more nadir shot of Virginia Beach is the point of land kind of in the middle left center. Norfolk a little bit more towards the top of the screen. The eastern shore of Virginia, the beginning of the Chesapeake Bay, the Tucks and Potomac rivers up there, and looking not quite all the way to D.C., but you can almost see Washington, D.C. around the very right of the screen. And this is coming over the northwest tip of Cuba, kind of heading southeast, and get to see a little bit of the Bahamas and the water around there, the beautiful colors that we've got a still shot of that you'll see, the very deep blue colors of the very deep ocean, and the light colors very shallow water.
Here's some of our exercise on board. We had a bicycle ergometer, a little stretch band there to work out, and our doctors, our medical folks said that we came back in great shape for the period of time that we're up there, considering we're up there for 14 days. And we attribute part of this, at least, to the fact that we exercised, all the crew exercised during the flight.
Again, right below me was John working on the ergometer, but we try to squeeze in where we can squeeze in and use this laptop computer for just a myriad of different purposes on board, as well as we can send home our mail on that.
Since it was close to spring break, I thought we'd try a little bungee jumping, and don't think that had been done before in space, so we want to claim it first. We probably didn't get the duration record, but we did some bungee jumping. This was during our day off, our half day off.
Floating is, like, for most of us, a dream come true. I mean, you always dream as a child if you can fly and float, and here you get the opportunity to do it. And so when we did have the opportunity, we did. Here they're playing volleyball with me here, or catch, I guess.
This is the day before entry. We're going over reviewing some of our procedures for re-entry. We're going through some of the checklists that we're going to use to make the entry. And Andy's over in the right seat working our pilot computer.
This is another laptop computer that we had to help us refresh ourselves and review the process we're going to do and we go through as we come around, intercept the heading alignment circle, pass it over the Kennedy Space Center, and make our turn to final into a landing. So we had it set up over on the pilot seat, and John and I worked quite a bit on it for the couple days before entry. And this is just a shot of what the simulation looks like as we're passing over the threshold of the KSC-15.
Getting into suits is quite an affair in space. When you don't think about the fact that you can't just put your pieces of clothes on the floor, pick them up one at a time, and get into them. It takes two people to get into these suits, and it really is quite an arrangement. It takes a good bit of time to get everybody all suited up.
Looking out the pilot's window here, we had a camcorder. This is as we're going into our thermal phase, which is our glow phase, or the area that we go through our thermal heating. The reflections you see off our backs, that's a picture of John there, and I'm on his right side. That's what we call, sometimes incorrectly, the plasma or the fire spikes that you see coming over top of through the payload bay windows, or through the overhead windows. The glow is some beautiful colors, and you can see we're just about through it. On my right window, you can look down and see the Earth again. This is our trajectory as we're coming across the country. The white line is our orbit if we had stayed in orbit, but now we're doing a cross range across the country to get back home.
Here's a shot of the actual runway, KSC, runway 33, taken out of the pilot's right-hand window, and the vehicle assembly building down to the right there. It really wasn't that bumpy on the approach. It's just hard to hold that camera steady. Beautiful day at the Kennedy Space Center. We come down the outer glide slope, and Andy lowers the gear at 300 feet. It's always amazing to me that this vehicle, which has been our home, our spaceship, for 14 days now comes back and lands like an airplane. And we're touching down about 207 knots here. We had one last test to perform. That was to deploy the landing drag chute, which we've made some modifications to. Deployed that just at the start of our derotation at 175 knots and worked very well. And very bright, light braking to bring us to a complete stop. In all, we flew 224 orbits around the Earth, some 5.8 million miles, and it was a great flight. We're glad to be back and happy to be able to tell you about it.